let's dive into recommendation systems. Now, I don't have to talk much about recommendation systems because you already know about it or you experience it in your day-to-day life. From Amazon products or YouTube videos or Netflix movies and series. I mean, it's there in every major applications which you use in your day-to-day life. Now, in the next few slides, we will take a quick tour on some of the major approaches or algorithms which is used in powering many of these applications to give you the recommendations or personalized recommendations to users. Now, the recommendation systems can be broadly classified into three different types. The first one is the traditional recommendation systems, which has been used for decades altogether, and many of the major systems still rely on these traditional recommendation systems. Some of the major algorithms which power them are collaborative filtering algorithms, or the content-based recommendation systems, or knowledge-based recommendation systems, and hybrid recommendation systems. Some of the defining characteristics of traditional recommendation systems is that it leverages data involving user item interactions. Like, say, for example, the ratings which you give, the likes which you give, or even your basic buying patterns also. And these are used for building these traditional recommendation systems. Now, they are very effective, or these traditional recommendation systems are very effective. However, they make one basic assumption. They assume that assume a kind of a linear assumptions between your user and item interactions. So when you get into a personalized space, when you get into personalized recommendations, in real world interactions are not always linear, and that's where deep learning based systems, recommendation systems, or deep learning based algorithms started getting used as recommendation systems. So some of the major ones involves multi-layer perceptron based recommendation systems, CNN based, RN based, neural attention based, and even now what is one of the major approaches is about transformers, using transformers for recommendation systems. So deep learning, as you know, deep learning algorithms are able to capture many of these non-linear relationships, and it's very good at capturing these lower level extractions of data. So these are used for in terms of powering the recommendation systems. Now, deep learning models obviously are good at learning non-linear relationships, but however they are all huge, and interpretability also always suffer in deep learning. Now, there was also this need for kind of recommendation systems which kind of learns on a continual basis and kinds of adapts to individual tastes, and that's where reinforcement learning algorithms started getting used as recommendation systems. So there are different types of reinforcement learning approaches to building recommendation systems, like, for example, the multi-banded recommendation system. We'll be using this multi-banded approaches for building these recommendation systems. And the other one are the traditional reinforcement learning approaches, like the Markov decision processes or temporal learning, or many of these approaches are used for under this traditional reinforcement learnings. And then nowadays deep reinforcement learnings are used because the amount of states or the number of states or action spaces which is there, or which would be there for typical personalized recommendation systems, are huge, and therefore deep reinforcement learnings algorithms are used widely in many of these recommendation systems. We'll get into, we'll do some of this deep learning based and other traditional based reinforcement learning based recommendation systems in some future posts. But currently now what we'll do is we'll be focusing on the multi-banded problem statement which will be used for building our recommendation systems.